Hello and welcome back to this tutorial on PostgreSQL clustering. In the previous videos we've looked at PostgreSQL itself. We've looked at using Barman as a backup and recovery manager, which takes replications effectively of the main database and stores them. Also takes regular backups and again stores them on a separate system. And then in the last video we looked at rep manager, which helps us with replication. Now we haven't actually seen the failover process. That's going to come in the next video, but what we have set up now is a PostgreSQL cluster where we have one primary database and two secondary databases. And again, just as a reminder that we have Postgres 1, Postgres 2, Postgres 3, and although Postgres 1 is currently the primary, we should usually design our cluster that all of the servers are the same spec, same layout, same disks, so that if we do failover, then Postgres 2 could be the primary, Postgres 3 could be the primary. We don't have to fail back, so we want to make sure that our servers are not called primary 1, secondary 2, etc. Otherwise it just makes things very confusing when you try and perform the failover process. But before we actually look at the different scenarios of failover and how we actually manage things going wrong in production, we need to speak a little bit about high availability configuration. And really what we're talking about here is how do we make sure that the business, the company, the applications that the company is running stay available as much as possible. When you do anything, any training about data security, you will learn the triad, as it's called, of confidentiality, integrity and availability. And although we might not think of availability as a security issue, if somebody is able to make our system not be available, then that's obviously a security issue, because it means somebody can attack our business by making us not able to provide the services or the applications that we mean to. So depending on the company that you work at, depending on your risk appetite, your HA configuration might be as simple as, if there's a problem, I have to drive into the office, I run a few things, I change over a few databases, and then the solution can continue, the service can continue, maybe within 30 minutes, 1 hour or whatever. As long as we don't lose data, maybe the recovery time objective is not particularly great. However, in another scenario, if you think of the sort of bigger companies like your Facebooks and your Google, they aim for not ever having downtime, right? So even if they're doing maintenance, they try and design it in a way that says the system is always available. So if one of their database instances or one of the application instances or anything else, if that is in use and then it falls over, you don't want anyone to see an error. You want the system to be able to take steps of pointing to a different database server, running up a new database server, whatever it might be, effectively just to make sure that your system's always available. Now, technically, there isn't really a lot of difference between making a system slightly highly available and making a system very highly available. So when you talk about, is it available 99.9% of the time, is available 99.999% of the time, most of the mechanisms you use will be the same. The only difference for the most part is both the number of backup sort of replicas and instances that you have available. Obviously, the more you have available, then the less risk it is if one instance out of 100 or 1,000 instances goes wrong. And also the automation of what happens, because ideally you want the system to fail over, if it does need to fail over, in a way that's invisible to the end user. So I could live with maybe using an application like, let's say, shopping on Amazon. If I go and I click checkout and it takes a couple of seconds longer, then that's fine. I can live with that if it happens every now and again, even if under the covers the system is saying, oh, this database is broken, I need to take it offline, I need to bring another database instance online, and I'm going to do all of that automatically. So technically there isn't a lot of difference, but you should plan what you want to do on the basis of how important it is to get your system back online as quick as possible. So in most cases what we're really talking about is quite simply removing any single point of failure in your system. Obviously, a single point of failure means that when something goes wrong, which it will go wrong, every server in the world is going to break at some point, every application is going to break at some point, every network is going to break, every data center, every cloud provider. We've seen it recently with some of the big CDN providers. Even people like Cloudflare have their days where things are not available. So we need to say, right, I don't want any one problem to make my application fall over. And so mostly we're talking about duplication here, duplication of each part of the system. Now, you might have heard these phrases before: business continuity and disaster recovery. Now, if you have a highly available system, you usually have good business continuity, right? Because those extra instances of data, those extra copies, those extra applications mean that you're more immune to a single failure. As long as you've set things up correctly, that single failure gets taken out of circuit automatically and the application continues. That's what business continuity is about, and that really is the ideal scenario. But the sort of indirectly related concept of disaster recovery says, well, what happens if something really bad happens, if something does take down my application? And usually we'd be talking here about a significant data center incident. So what happens if the entire data center goes down? Shouldn't happen, but it does happen sometimes. Or what happens if your main database gets encrypted by ransomware? You've got a disaster. How quickly are you going to be able to recover from that? But mostly here, high availability, we're talking about business continuity, good uptime, which almost invariably just means duplicating parts of the system so that we have that immunity from a single point of failure. Now, just as a sort of a thing to remember, high availability is required if you want a failover system, which is a system that allows you to switch out a bad server or database and switch in a good server or database. You need a high availability system because you need these other pieces of equipment on standby, perhaps even in circuit. They could be live servers, they could be one of many servers. But if you want that ability to switch over from a bad system to a good system, you're going to need a high availability design. But just because you have high availability doesn't mean that you have a failover solution. So it is possible to duplicate parts of your system, add in your extra database replicas, add in your extra application servers, etc., and still not have a failover solution. The failover is the thing that says, I'm going to switch all my traffic from a bad system to a good system, and that involves a little bit more work than just duplicating things. So if we take a look at an example, so if you had the most simple, well, maybe not the most simple, a very simple example of an application which is on this side running on some kind of server, doesn't matter if it's virtual or physical, and then there's going to be some kind of network connection probably, and then a database application running on a database server. So it's a fairly kind of traditional application setup, but of course hopefully you can see here that there are 5 single points of failure at least. So the server running the application could fall over in some way. Doesn't matter why or how, it just matters that it can fall over. The application itself could fall over for a number of different reasons. The network could go down. We often think of the network, we design with a network being really, resilient and it always works and it's always there. But actually, if we're honest, we know that the network does also go down temporarily, longer term, or maybe even something like a network switch in the data center might get broken and it might take a number of hours to get somebody to go and change that physical switch over. And then likewise on the right hand side you have a server which is actually running the database, and you have the database itself. Now if any one of these 5 things breaks, then your whole system's broken. So that's what a single point of failure means. A database server is going to break at some point, an app server is going to break. Even something simple like running Windows updates or Linux updates, how are you going to do that? Because while you do that, one side of this is going to go down. How are people going to access your application if you're rebooting your server for application upgrades? So in most cases we're basically going to do this. So in this case, all we've done is we've duplicated the application server. So there's server 1, server 2, and we duplicated the database server 1 and 2. If we're using a cloud provider or a sort of a hosting provider of a high quality, I guess, they're likely to have multiple zones, and these fault zones are designed so that it is possible to have a fault that takes out an entire zone. So a zone would be a single internet connection, or at least a minimum of a single internet connection, one or more backup generators, one or more air conditioning systems, one or more power supply systems. You kind of get the idea. But of course, if the air conditioning control system breaks down in zone 1, they might have to shut down all of the machines in zone 1, and that could be both of these servers. So what you do, well, you have another zone that has a separate air conditioning system, a separate internet connection, a separate backup generator. You get the idea. And so theoretically, if you get a problem in zone 1, you have time to fix it before you are likely to have a problem in zone 2. So if the air conditioning breaks in here, you call the air conditioning engineer to go to fix it, and then they fix it within 30 minutes or whatever, and you hope that there isn't a problem in the other zone. So by running these servers in separate zones, you have a little bit of extra resilience, which is kind of the crux of high availability. And in this case, we're showing a network where the application itself is aware of multiple database servers, and this application is also aware of both of those servers. So in this example, it's actually up to the application itself to be able to deal with the fact that one or more of these other databases might go offline, and it needs to be able to cope with that. So the sorts of things we've just seen in this diagram, we're going to have a client application with one or more connection strings. We've probably got some kind of load balancing. We didn't really see that in the diagram, but load balancing enables you either just to get a scale out of your system. So let's imagine you have a system like Facebook or Twitter. Most of what happens is data is read from a database. Most data is not written, it's mostly read. So what you do when you have lots more read databases, lots of read-only replicas, and maybe only one writable database, and using load balancing, you can spread all of those reads across your 10, 20, 50, 100, 1,000 replicas, so that you're not putting all of the traffic in one place. So load balancing is often useful, and we're going to see a little bit in this video about how we automate that load balancing for these kind of failover scenarios. Probably, depending on what technology you use, you're going to need some kind of IP switchover. So you either need a load balanced IP, which we'll see in the next slide, which is able to point to the correct servers, the correct database servers, for example, or you'd have a virtual IP, which is something that a service can say to the network, I'm going to have the IP address now because I'm online, but then if I go offline, then another instance says, oh, actually I'm going to have the IP now, so that the IP effectively moves using effectively ARP calls on the network, and then that allows the application to not have to worry about which database is or isn't online. And then you're going to have multiple instances of the database. I mean, people talk about having a minimum of 3 as a high availability system. The problem with having 2 is if one of those 2 goes offline, you're running against the clock, hoping that the last one doesn't go offline. Because if you lose one of your 2, you're only left with one server to do everything. Whereas if you have 3, you could have one of them fail. You might need to restart another one, but you've always got 2 there to enable your system to carry on working. So it's usually 3, but not everybody has 3. Now, when we actually look at what a load balancer might look like, it's not necessarily a great diagram, because like most things, a load balancer, if it's a separate server, will also need to be duplicated for the same reasons that the application database servers need to be duplicated. In other words, if zone 1 goes down, it's going to take down this instance of the load balancer. So there's more than one instance. There could be 2, there could be 3, there could be more. But importantly, these talk to each other so they know what's going on. But more importantly, although this looks like it's pointing to the load balancer here, what actually happens is both of these apps point to the same IP address, and that IP address will either be owned by this instance when it's running, or if that fails, then the IP address will be assigned to this instance, and they will both point to that automatically, depending obviously whether it's just a load balancer or the whole zone that's gone down. And then the load balancer is responsible for spreading those requests across a number of back-end databases. Now again, I've drawn 2 here. Our test system has 3, and you could have tens or hundreds of databases there. And the load balancer's job is simply to say, right, you want to read data, so I can send you to any one of the read-only databases, or you want to write data, I need to send you to the writable database, whichever one that happens to be. So what are our options? Well, the problem with having an open source project like PostgreSQL is that you tend to get all of these different projects start up to achieve similar but different jobs. Okay, so the multiple hosts one, we're going to look at an example of that using our test application. That's kind of quite cool. It's quite a basic system. It's not brilliant, but it is simple and it doesn't involve any extra work. But then you start getting into the area of proxies, so software proxies, hardware proxies. Keep Alive D is sort of like a proxy daemon, but rather than running as a load balancer, you can get it to run on each database server itself. We'll look at that as well. Those 3, the 2 proxies and Keep Alive, are very general purpose sort of high availability tools, and you'll see them used in lots of different places. But because they're not specific to PostgreSQL, they're not necessarily perfect for a number of different reasons, which we'll see. And then after that, we have things that are more specific to Postgres. So you've got things like Patroni, which is one, I don't even really know what to call it. It's called a template, but it's a relatively complicated system of sort of witnesses and proxies that basically watch your Postgres cluster, see what's going on. They can then update the proxy to say, yeah, this server's offline, this server's online, all the rest of it. But I found, as with a lot of these tools, that they're quite hard to understand the documentation. It's quite hard sometimes to understand what the project is actually aiming to do and how many different moving parts are involved. Because let's be honest, I don't want to have to be an expert on Patroni just to be an expert on Postgres. I want these tools to kind of work out of the box and to be understandable. There are also cloud-specific services. Obviously, if you've got things like Postgres for Azure, for example, then you're going to get a load balancer that's going to do this work for you automatically. Probably under the covers, it's going to be HAProxy or something like that. But of course, using a cloud system, we're saying, I don't want to know the details. I just need to know that when I call that endpoint, it's going to find me a database, and that database is going to be online. And then there are a number of other ones, PG Cluster, PG Pool, number of sort of open source projects, different stages of maturity, different levels of documentation. Some of them even appear to be abandoned. It's quite hard to tell sometimes. So they're most specific to Postgres, but they're also in a state that can make them quite hard to understand. So we're going to go through and look at a couple of these, and we're going to start with the idea of multiple hosts. So when you have a database driver, obviously you have your code, whatever language that's in, Java, C#, JavaScript, whatever you fancy. When it talks to the database, it has to use a driver because the actual database is going to speak some kind of binary protocol, and your code is not going to speak that protocol natively. So your driver is then responsible for turning your code level calls, you know, select, delete, update, whatever they are, into something that the database engine itself is going to understand. Now, what the Postgres driver supports is the ability to specify more than one host name or host IP address in a connection string. And then also you have to add a target session attribute. So you could say you can use any of these hosts, which are all read-only replicas, for example, for a target session attribute of read-only. But in the case of read-write, you have to use these set of databases because they're the writable master databases. Now, that's pretty cool, and there are wrappers in most languages. So the example we're going to look at is going to be in .NET, and that's supported in .NET. And what the driver actually does is it will say, right, you're looking for, example, a read-only replica. I'm going to try the first host in the list and say, are you read-only? If it says yes, then that's the host it's going to use. If it says no, then the client will move on to the next host and then say, are you read-only? And if that host says yes, it will use that one. If it says no, it will carry on. And eventually, obviously, if none of them are read-only, then you'll get an error because it doesn't support what you're trying to do with the connection. Now, there is a random option which sort of adds its own complications to it, but by default, it will read through those hosts one after the other, and it remembers the status of it for a short period of time, maybe about 5 seconds. So if it checks one database and that database is offline, or if it says no, I'm read only, or I'm read write, or whatever it says, so remember that for a short time, but it's not going to remember that for too long, because if you're failing over and you're swapping database servers, you need the application to catch up quite quickly. You don't want it to remember what it used to be. So the random option can add sort of some interest, but we're not really going to look at that at the moment. So this gives us a very simple automatic failover for multiple database servers, right? So we can use this on the replica that we have in our test systems. The problem here is that if any of the servers are down, then the connection is going to time out. So remember that this is all happening at the application end, at the client side. So if you've told it that you can go to Postgres 1, Postgres 2, Postgres 3 to look for a read-only server, if it goes to Postgres 1 and Postgres 1 is down, well, if it's down, it can't say what you're doing because the database server's not going to answer because it's down. So what's going to happen, it's going to sit there, it's going to wait a number of seconds, and then it's going to give up and fail and then move on to the next host. So it will still work, but you're going to incur a certain amount of latency until you either get that server updated again and online again, or you update the clients to remove that server from the connection string, which might or might not be easy for you. In a lot of cases that might take a number of seconds, a number of minutes, and if you've got multiple applications that all use that same connection string, then you might have a lot of applications to deploy. So that's the big problem with that. And again, you can't assume that all libraries support it. So we got caught out with one particular system was using a node library for Postgres, and it didn't support multiple hosts, and that was a real pain for us. But this is what it basically looks like. We'll see a real example in a second. So instead of just saying host is server 1, you can say host is server 1 and server 2. So if server 1 is the primary and we want a read write session here, then you're going to have no problem. If server 1 is online, it's going to connect to server 1. It's going to say, are you read write? And server 1's going to say yes, and that's all going to be grand, and life is good. So imagine we've now said this is a planned failover. So we've now told server 2 to become the primary, and server 1 is now a replica. So what's going to happen now? Well, we don't have the random flag set, so it's going to say to server 1, the first one in the list, are you read write? And server 1 is going to say no. So then it's going to ask server 2 and say, server 2, are you read write? Server 2 is going to say yes, and then everything's going to be good. Now, okay, there's been an extra connection made to server 1 that was not necessary, but we're probably talking about single, maybe double digit milliseconds, not really the end of the world. And what we've actually had there is a very simple immunity to a failover scenario. We failed over and the client doesn't know any difference, it's still going to work. So that's fine. However, what happens when server 1 goes offline? Now, it doesn't matter that server 1 is not the one we're looking for, because we're looking for a read write, because we've told this connection string, the read write connection string, that the first server to try is server 1. So our application is going to say to server 1, are you read write? And server 1 is not going to answer because server 1's gone offline. What's going to happen? Like we said before, it's going to time out, and then it's going to try server 2, and then server 2 is going to be fine. It's going to say, yeah, I'm read write, that's all good, and then we carry on. So lots and lots of database calls are now going to start to have significant latency in them. Now, in a planned scenario, this might not be a major problem. If you were rebooting this and you did it in the evening when your system was quiet, yeah, a few users might get a bit of extra latency, but after maybe 20-30 seconds, server 1's going to be up and running again. You may or may not fail back, and everything's going to be good. But if this is an unplanned error, and server 1's gone offline for a reason that you don't really understand, and you can't get it back online, then you're now starting to create significant latency for lots of your users, until such a point as you can deploy an updated application that only contains server 2 in the connection string. So let's look at how this works in real life. So what I've added, if I bring up VirtualBox, we have Postgres 1, 2, and 3 like we had before. They're just running Postgres. Postgres 1 is the primary at the moment, and it's replicating to Postgres 2 and to Postgres 3. Barman 1 is running, but we're not really interested in that at the moment. That's there to take backups and stuff like that. And I've added another VM which has HAProxy installed, and which is going to be used for our demonstration of proxying. But at the minute, we're not going to be using this proxy system. We're just going to use Postgres 1, 2, and 3 and our test application. So let's open our test application. Now, we showed you this before. If I just run it up a second so you can see what it looks like. We have a number of pages here. So these ones here will use the connection string for Postgres 1 server, Postgres 2 server, Postgres 3 server. You can see they're all performing the same queries. And this will just use the general connection string. That's the one that we're going to be playing around with. So if we go and actually look at what these look like, they're the server specific ones. But if we look here, you should be able to see that we have multiple host names in this one. So this is the primary one. This is the one that we want to be read write. So the session attribute is actually primary. And you can see that we put 201 first, which is Postgres 1, 202 second, Postgres 2, and 203 third, Postgres 3, Postgres 1, Postgres 2, Postgres 3. That's fine. That's correct. That means at the moment everything's good, because it's going to try Postgres 1 first, and Postgres 1 is the primary, so that's going to be fine. And then in the read-only version, you can see that we have 202, which is Postgres 2, 203, which is Postgres 3, and then 201, which is Postgres 1. Now, why have we done it that way around? Well, this prefers a standby. So if we put Postgres 1 first, they said, well, we prefer a standby, then there's a chance it might say, well, I'm just going to use the primary, because that, I know you prefer a standby, but you can read from this as well. So what we want to do is say, no, I want you to start by trying Postgres 2 and 3. I'm paying for them as replicas. I might as well make use of them by starting with those. But of course, if a failover does happen, and let's say that Postgres 2 gets switched off and Postgres 3 becomes the primary, then Postgres 1 is still there at the end of the list to be used for a secondary. So we're kind of covering all our bases. We have all three in both places. Now if we actually open, where's that? That's in here. This page, this first page only uses the read-only connection, whereas edit, delete, and create new all use the read-write connection. So hopefully this will work. If I do, lion, witch, wardrobe, because I can't be bothered to write the whole thing. CS Lewis and create. So we can see here that the general connection works, and this sort of, which is using the read-only connection, works as well. So that seems okay, but let's see what happens when we go into, let's say, Postgres 2. Now remember, this was the first of the read-only servers in a list. So in here, that one there is Postgres 2. What happens if we stop this? So I'm going to stop the Postgres service. Now that's the kind of thing that would happen in real life for any number of different reasons. So that's fine, it's gone down. The primary is still running, and Postgres 3 is still replicating. So the system should still be able to work correctly. But watch what happens here. I want you to look at the little icon on the tab, which will show you it loading. If I just go to home first, if I go to books, see what's happening here? It actually was slow, and then it eventually timed out on Postgres 2 and then went to Postgres 3 and was able to do what it wants. Now, if I go back quickly enough, See, that's slow again. Now if I go back and I go back again, you can see that the browser's caching some of this, and the connection's caching some of it. But eventually that caching of the state of that connection will time out again. If I go back again, you can see here. Now in this example, you might not think that's terrible. It's not really bad, but it's quite bad. And if you've got hundreds or thousands of users, that's going to start adding up very quickly, and you're going to potentially start having other problems with your application servers because they might start running out of database connections as everyone's kind of waiting for it. So this kind of multiple host scenario it's kind of okay. It's better than nothing, but it's not perfect, as we've seen there, because once that server goes down, then you're basically going to have all that latency. And obviously if you actually failed over completely, which we're not going to do quite yet, if I failed over so that Postgres 1 became the say Postgres 2 became the primary, Postgres 1 became a secondary, again there's lots of other things that this is not easily going to be able to handle, lots of different scenarios. So I would always use it by default if you've got nothing else. But what we're going to look at next is the use of HAProxy. So not there, but there. And HAProxy is, as we say, a software proxies, and of course they're popular mainly because it's pretty low cost. You can run HAProxy in a very small, very cheap Linux server, and we're going to look at health checks because health checks are important. We can't just load balance across a number of endpoints. We kind of want HAProxy to take the responsibility for saying, if this server's not up and running, I'm not going to send any traffic to it. And the reason for that is I'd much rather my client just points to one IP address, which will be HAProxy, and then HAProxy can do all the difficult stuff about working out what is and isn't running. Now, there are some costs to this, as you might imagine. So in most cases, you're going to need to be running 2 or 3 more VMs to actually give HAProxy itself a high availability architecture. Now, you might not think that's a big deal if you're already paying tens of thousands of pounds a month on hosting costs, then it's going to be pennies in the scheme of it. But if you're actually a small business and you're only spending, you know, a couple of £100 a month, then adding another 2 or 3 VMs, especially if they're on the cloud, could easily be another £100 a month just for 3 small VMs. So there's going to be a cost to it. There's going to be a maintenance cost to it. You're going to have to make sure that you know how to update these servers with their OS updates and restart them without things going offline, because it might all be great having a high availability system, but you need to know that these things aren't perfect. What is the scenario? What's the proper way to take one of the proxy instances out of circuit, out of the group, so that we can update it, reboot it, do whatever we need without any connections erroring in the process. So there's going to be some potentially maintenance and stuff to do, and depending on how you actually set up your HAProxy, if you do go high availability, which we won't demonstrate, we'll just show a single instance, then you're also going to need the ability to have a movable virtual IP address, because you're going to need to move that IP address between different instances of HAProxy depending on which one's online and which one isn't online. So again, that uses ARP announcements, which is a network message which says the interface with MAC address blah 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 owns the IP address XYZ. So in the future, if you've got any messages for that IP address, please send them to me. Now, the reason I mention that is because if you go to somewhere like Azure, well, the Azure virtual networks don't support ARP announcements. So anything that uses ARP is not even going to work on Azure using VMs. You would have to use a cloud service, and that might cost you more money. It might cost you less, but it might cost you more money as well. So there's definitely some gotchas here. But what we're going to look at in a minute is how to set up HAProxy from the beginning. It's very, very easy because we're talking about one configuration file and one server. So that side of things is quite easy. And we'll also take a look at what I had to do to Postgres to make it play nice with HAProxy. and then what we'll do is we'll develop HAProxy over a number of iterations to go from a very simple but ineffective proxy right through to a proxy that has health checks. So firstly, I've added a vagrant file. This will all be in the notes attached, and it's basically the same as all of the other Postgres servers. There isn't anything particularly interesting here, given it its own IP address. And all I've done is installed HAProxy package as part of the setup for the vagrant file. So that kind of quite straightforward. And you can see that I've put in 3 different configuration files here. So we're going to start with the basic one. We're going to copy it over. We're going to see what happens. And then we're going to apply the next one and the next one, and we'll talk through those. But if we just go back into the proxy itself, what we want to do initially is we want to copy over the first file here into the location. So this here is the default location for the HAProxy config file, as literally one file, and that's it. I guess you can split the configuration into multiple files, but I've never really needed to do that, and that's it. So once you've installed HAProxy, one config file, and that's all we need to do. So let's actually have a look in this file and kind of talk through these. Now, most of this top bit is what you get by default anyway. So there's various things about saying, you know, it runs with a certain user and group, it logs to various places, it runs as a daemon, and it has some basically set up fake kind of SSL connections for certs and all the rest of it. Now, this stuff here, again, most of this is just things I've copied from elsewhere. The insecure fork wanted was important. I can't remember off the top of my head why, but it's to do with the way that it calls the external checks for Postgres, and I think you get an error if you don't have that in place, but unfortunately I can't really remember. Then you have defaults. So the defaults apply to all of your groups below unless they're overridden. So again, everything's TCP mode, so we're not running HAProxy as an HTTP proxy, it's just a TCP proxy because obviously PostgreSQL is not an HTTP application. Various different things here, again, most of which not really particularly important. Now this one here is really important because we're going to get a nice web page, which is probably here somewhere. And this page is what HAProxy actually shows you by default. So you don't have to do anything to get this other than make sure that you've got, you know, listen stats, and then you can see here it's running HTTP, port number, enable it, refresh every 5 seconds, blah, blah, blah. So you don't have to do anything particularly weird, but this is really important for working out what's going on with your proxy, the sort of current state of it and stuff like that. In fact, the first thing I'm going to do is, or quick thing I'm going to do is just reload or restart HAProxy. And the reason I'm going to do that is because you'll see that that web page turned to grey, and that's kind of important, which you'll find out in a minute. And then what we have is we have the concept of front ends and the concept of back ends. So the front end is port numbers and mode. So the front end for our read-write connection. Now, at the minute, these aren't any different on HAProxy because of the way we've configured them. But for now, we've kept the group separate because it makes the config 1 and config 2 make more sense. So we have a read-write endpoint. It's on a particular port 5000. Choose whichever port you like. And then it says that the default backend to use is a backend called read-write, which we've got just down the bottom there. So that's easy enough. And exactly the same for the read-only connection. We just have a different port number and a different backend. Now, obviously, HAProxy is designed to be super sort of complex and powerful if you need it to be. So you can have multiple backends, you can have different backends, you can have a default backend and then a fallback backend. So that's why there seems to be a lot of code here just to do something quite simple. But don't worry too much about it, because once you see the big config files, then it won't look so bad anyway. So for each of those front ends, we have a back end. The back end here, there's various things to do with what happens if one of the servers goes down. So if all of these servers go off, then what it will do is actually any existing sessions which are going through the proxy will actually be shut down by the system. Again, not really that important for test purposes, but the sorts of things you might want to think about if you're using it in production. And then all I've done is I've said there's a server called Postgres 1, Postgres 2, Postgres 3, and the endpoint it actually uses is 5432, not the default, which would be HTTP port 80, I believe. So again, identical for the read write and the read only, because we're not doing anything particularly clever. So we're running this configuration. You can see what it looks like here. So you can see 3 lines for this back end, 3 lines for that back end, and then a single line for both of the front ends. And you can see here it's saying, yep, the connection is open on both of them. But the important thing is there are 3 grey lines which don't look particularly enabled. But the point is this here, there's no check. We're not doing any kind of health check. So there's no way HAProxy knows if it's online or not. As far as it's concerned, it's online because it's listed in the configuration. So this is kind of fine for now. Obviously everything's up and running. What we're going to do is we're going to replace our read-only connection with this one here, and I'll show you what the difference is in a minute. Unfortunately you can't comment things out in JSON, so that's why it's in another file. So the first thing to notice is that we only have a single IP address now. So this is the IP address of HAProxy, or the server that HAProxy is running on. And you'll see here the port number is 5001. Why is it 5001? Well, 5001 was the port that we used for the read-only front end. It doesn't actually show you there, but it does show you in the configuration file. So if you remember, in here we had the read-only was 5001, so that's the port there. So that's what that is for. All of those bits are all the same. The only other bit is because there's only a single host in there, we can't use target session attributes. Even if this is for a read-only one, if we put target session attributes, then the driver will throw an error saying you can't have target session if you've only got one, which is, yeah, kind of makes sense. It's a bit annoying, but there you go. So now this is going to talk via HAProxy to that server. I need to stop and start it again. So if I run this up, and if I go to these, they should all work absolutely fine, because it's going via HAProxy. Just all HAProxy is doing is saying, right, you've got a request for 5001. Now what do I do with that? I send it to the read-only backend, which is basically one of these round robin through those, and then they will all work. Now Postgres 1 is obviously primary, so this does mean that at the moment the primary server is also getting 1/3 of all of the read requests, which is not great, but we'll need to fix that in a little while. But importantly, because there's no check on these, if I go into Postgres 2 and I stop it again, this isn't going to change. HAProxy doesn't know anything about it because it's got no way of checking whether that server is online or not. So if you go back to our application now and we go back to books, we're going to have our same problem again. Or in this one, I think it's actually, yeah, so this is actually try to open a connection to a database that isn't there, and then that's all got knackered. So you can see here that, you know, eventually it would work on one of them, or HAProxy should eventually find it on one of them, but at the moment it's struggling because that server's gone down. So it's kind of broken because HAProxy doesn't know anything about it. Let's just, it doesn't seem to be catching up, so let's just start that back up again. Now if we run it again, hopefully at some point, oh, I don't know what I've done now. Managed to completely break it. Oh, because it's sitting in there, that's why. So obviously that's going to be fine again. So that's kind of a bit disappointing, isn't it? It's a bit like saying, well, what's the point of having a proxy if it's not going to be able to tell which servers are or aren't available? And we already mentioned that at the moment this is supposed to be only for read writes, but at the minute it's pointing to all three. Now, of course, you could say, well, why don't I just comment these two out? That's going to work, right? Well, it is, but what happens if I fail over the database and I promote Postgres 2 to be primary? Then this backend is going to be completely broken because it's still pointing to Postgres 1, and Postgres 1 isn't going to be primary. What it would involve would be somehow editing this, going back in, changing this, reloading HAProxy. It sounds messy, and it would be messy. Really what you want is you want something that looks a bit like this, where it has all of them in there, but it kind of runs a little bit of a process, a bit like this does, where it says, you're after primary, so I'm going to look through these and find you the primary. And also, if the server's completely down, I'm not even going to worry about it. I'm just going to switch it out of the back end and use the ones that are remaining. So we have another version of HAconfig which we can look at and which we're going to copy over in a second. So HAProxy 1, all of the top parts exactly the same. So we've added something in here, and what we've done is we've added this line for each of the backends. So that's PostgreSQL check. PostgreSQL check, in fact, that's actually missing something. So let's put this in before I forget. What this is saying is that, oh, I don't know what I did there. What it's saying is we're going to use a built-in server check with HAProxy specifically designed for PostgreSQL. And when we make that call, we're going to use the user HAProxy when we call into these servers. Now, what is this doing? Well, it's saying you're going to check using this option that we set at an interval of 5 seconds. There's a fast interval of 2. I don't really know what all of these mean exactly. I'm gonna wait for it to be down for 5 seconds, and if it's down for 5 seconds, I'm going to mark it as failed, and then I need to read it as valid for 2 times before I turn it back on again. But again, all configurable, all up to you to try and balance not switching a server out too quickly just because there was an error, maybe the network went down briefly, but also not leaving it out of circuit for too long if it's actually come back alive again. So we do that, and we do exactly the same again. So at the minute, these are still 2 identical configurations, so they're not really providing the read-write versus the read-only functionality. But for now, it will give us a little bit more functionality. So what I need to do is I need to come and copy that file over the top of the existing one, and then I need to restart this, and hopefully you'll see that these have now changed color. So instead of being grey, they're now green, and if you look here, the status, it will show you how long it's been up for rather than no check, which is what it said before. But also it tells you there's a level 7, in other words an application level check, and that was okay. Now all of that's built into the Postgres check. We haven't had to particularly do anything. But the nice thing about this is, we'll just show you quickly, is what happens now if we stop this. You'll notice in the background on that web app, after not very long, you'll see that 2 has gone yellow, so it's detected that something broke, and then eventually it's gone red, which said, right, I let it go down once, but once it went down a second time, I've now switched it out. So any requests that come are not going to be sent to Postgres 2 anymore. What have I done? I've pasted something in there. Whereas if I start it back up again, what will happen is it will eventually pass the check. And Postgres 2, it will come up again, it will go green eventually. So now it's back in circuit. So this is the health check we were talking about that's really vital, so that your systems are not being reached when they're not supposed to be reached, when they're unreachable, or maybe just when you want to take it down because you're doing updates and stuff like that. So if you're updating the OS on this server, you could stop PostgreSQL, which would cause it to be taken out of the load balancer automatically, and then you could do all your updates, reboot it, do whatever, start the service up again. Eventually it would go green again, and then everything would be happy. So let's look at what this kind of means for our existing application here. So if we go back to here, so remember we're still talking to HAProxy at this point, and we're talking to the read-only endpoints. So now if I go to any of these, now Postgres 2 is down, so this one is going to time out, which we expect because it's not there at the minute. But all of these others are going to work absolutely fine. They're never going to even try to use Postgres 2 because HAProxy knows it's down, and otherwise it's just sharing the work between Postgres 3 and Postgres 1. Like most proxies, you can configure how it you can weight the server. So you could say, I want more stuff to go to Postgres 3 than Postgres 1. You could say I want it just to go round robin, and if you're tracking connections you can even get it to try and use the one with the least active connections, but again I'll leave that as an exercise for you. So we've kind of got fairly close to what we want, but we're still lacking that one really important thing. So if we look here, our read our read write version up here is still not going to work properly, and the reason is, as we mentioned earlier, if I just put that to port 5000, so that should work, but depending on what it does and which order it picks something up in, if we go to books and if I do delete, it might or might not work. There you go, can't execute delete in a read-only transaction. What's happened there? It's gone to Postgres 2 or Postgres 3. Well, it would be Postgres 3 because Postgres 2's stopped, is it? Yeah, still stopped. Start that back up. It's gone to a read-only one to try and do a delete transaction, and it's not going to work. So that's the problem. The problem I want to solve now is saying, well, how do we kind of say, I want to do a check for read-write for these servers, and then I want to do a check for read-only for these same 3 servers, and only use the correct ones. Now this is where it gets difficult, and this is one of those things again where I'm surprised no one's really solved it yet. Somebody's obviously written this PG check, but all it actually does is it basically goes to the server and tries to log in, and if it gets a login sort of response, it knows the server's up and running. If it gets anything else, it knows it isn't. So it's very simple, but of course it's not really doing what we want to do. What we want to do is we want to run something called PG is in recovery, which is effectively a method that returns true if you're a replica and false if you're the primary, because if we use that, then we can only mark the correct one to be primary and the correct ones to be secondary. So that's pretty cool. How do we do that? Well, unfortunately the only way we can do it is using this gist here. So again, you'll find the link in the PowerPoint slides in the GitHub project, but effectively somebody's worked out how to do this using the most impressive but also the most long-winded way you could possibly do it with HAProxy. And the truth is HAProxy actually supports, as well as like the Postgres check and a web check, the kind of simple ones, you can also actually send TCP messages at a really low level and then say, I expect this data to come back. Now wait for it, because this is going to be quite frightening. There's a few bits here which you don't worry too much about that we've added, which basically say there should only ever be a single master on the back end. If there isn't, that means something's gone wrong, so don't send anything to anywhere, because if you end up with a split brain and 2 primaries, you can end up all over it in a big mess. So it kind of got a thing there which just checks for that. But other than that, this whole big bit where are we gone? Here. So it's kind of commented, you'll find it all in that gist, but what it's basically doing is sending some binary data. You can see here that, as you might expect, this is effectively doing a login. So protocol version, the user is HAProxy, the database is Postgres, and then a null terminator. And then it's going to send an auth request. The packet length is 8, and then it's going to come back saying expect binary. Expect, the server's going to say 52, and it's going to send 8, it's going to send 0, and then we're going to send, you can see with the commented out bit, a simple query which is select PG is in recovery. Now these things are all encoded in hex, so for instance if you wanted to do PG is in recovery in hex, then you can go to like an online hex encoder and you could encode whatever you want, like that, Control V, and do encode. You can see there 706 293B, 706 293B. So that's what this is. It's just a text of PGs in recovery, but they've effectively built it all out in a way that would do what you would actually do if you're doing it from the command line, which is select PGs in recovery. And now the only difference between then the top one and the bottom one is the primary expect it to come back with an F, which is false, and the ASCII code for F is 66. If you're the read-only ones, then you'd expect in recovery to come back as true. T is ASCII code 74. So that's really the only difference here. We're still doing a check, but this time it's a TCP check and not a P-SQL check. So it's pretty long-winded, pretty nasty, but somebody's kind of done most of it for you. Now the only thing to bear in mind is that some of this is going to be different, particularly that line of with the user in it. Now we can encode HAProxy into hex just using an online site like that, but then obviously what we're going to have to do is make sure that the number of bytes is correct, because this is all needs to add up correctly. So it's like, and this is hex, so 28 hex bytes, which is all of this stuff. So it's a little bit of a kind of playing around. But the other thing is we'll need to go into the database, and we need to do two things. We'll need to create the user, so we can do that really easy. I've already done it, but you can just do create, it's not login, create user, HAProxy, and that's all we need. We'll just do that. By default, we're running as Postgres user. It will allow us to connect and run that, which is all fine. And then what we need to do is we need to edit the PG HBA conf, which is here, PG HBA conf. And then we need to, so there's two things we need to do. The first of them is that we need to make sure that HAProxy can access the Postgres database from 192.168.56.211/32, which is our HAProxy, and if it comes in, it's then going to have to trust it. And then the other thing that we need to do is make sure that this last general password protected one covers the IP range for our proxy, because all the connections to the database are now going to come by the proxy. So if we had that locked down to 56.1, which is my host machine, then that's obviously not going to work, because HAProxy is actually going to proxy the connections. So we've kind of added a couple of bits, but it's not particularly difficult. But now what we want to do, just to kind of demonstrate that working, is this time we're going to copy HAProxy 2 over the top of HAProxy. We're going to restart again, and hopefully what's going to happen now, so you probably noticed that. So in terms of the read write, Postgres 1 shows as green because the checker said yes, I'm not in recovery, so I am the primary. The other two have said yes, we are in recovery, so those have both failed the check, so that is correct. There's one server for that, and likewise the reverse is that Postgres 1 is not a read-only replica, so that's not in the set. but Postgres 2 and Postgres 3 both are. So what that means for our app now, see we've got 5000 and 5001. So one of these is pointing to the read-only replica. Now we can't really test, I don't know if that actually worked, so let's do it again. We can't really test the read-only one because if it hits Postgres 1 it's still going to work, because Postgres 1 is a read and a write server, so that's not really going to tell us anything. But if we actually try and delete one of these now, it's worked, because delete is going to use the read-write connection, which is going to go via HAProxy, which is going to only hit the Postgres 1 server. Now, I don't particularly want to talk too much about this because I want to talk about this in the next video, but I'm just going to log in as Postgres. What I want to do is do a switch over. I think that's the syntax. Now I haven't actually tried this yet on my testing, so that was perhaps a little bit silly to do that, but oh, no, it's not going to work. It's going to time out. No, what I was going to do is I was going to show you that failing over would make these that green would disappear and 2 would become green and 1 would become red, and then 1 would become green down here and 2 would become red. I need to test the failover stuff before the next video and work out what's missing there. I suspect it is the fact that the Postgres user doesn't have auto sudo. So you know that when you do, like in Vagrant, if I do sudo here, I don't need to type in a password, and that's because there is a file underneath etc sudoers.d, and you can see that there's a Vagrant entry, and that Vagrant file basically says if you're the Vagrant user and you sudo, you don't need to type a password. Now I need to have that for Postgres as well, because when I'm on rep manager is going to log in as Postgres on the foreign machine, and it's going to try and run the sudo commands. That's a good example of what I said earlier, where testing is critical, because even though I thought I'd set everything up because I'd forgot to do that one step, then that's not actually happened. So that's kind of HAProxy setup. As you can see, it's a little bit messy, it's a little bit of a faff, but it does kind of work. The main downside, as I said, is the extra cost of the servers and the need to maintain a number of clones of it so that you can have high availability HAProxy as well. Now if we just pop back to the slides a second, there are hardware proxies that you can buy. It's obviously going to do pretty much exactly the same job as HAProxy was doing, but they're generally more reliable, they're more stable. If there are updates, they're usually a bit smaller and less frequent, because the hardware inside a hardware proxy is usually much more simple than obviously a general purpose virtual machine. Configured in a similar way to what we did with HAProxy, but probably likely to be a lot more expensive. And if you're in a hosting provider, it might not even be available for you anyway. You will still need the duplication. You still need at least 2 units to work for high availability, but to all intents and purposes, it has most of the same pros and cons as the software proxy. It's just maybe a little bit more reliable, but a little bit more expensive. Now, Keep Alive D is a slightly different approach, where you run a daemon on each of the database servers. So the nice thing about that is you don't need the HAProxy instances. So this is going to be a cheaper scenario, and it kind of does a similar job really to HAProxy. So it still has a health check, and it has a cluster of these Keep Alive daemons across the database cluster, which are basically talking between them. The documentation is a bit of a pig, so I did manage to set it up, but it took me quite some time to get my head around the sort of the naming and the concepts it was using. And like a lot of projects, the documentation is kind of okay, but I wouldn't say it's great. So when you're new to it and you're trying to understand it, it kind of keeps jumping between 2 slightly different concepts, which are both supported in Keep Alive D. But the other thing is, it does rely on this VERP protocol, which is effectively the ability to move virtual IP addresses around. So a little bit like what HAProxy can do, Keep Alive D can kind of go, right, I'm offline, and another instance can say, well, I'm online, I'll take that IP and I'll become the new point of contact, the new kind of load balancer entry point, and it can move those IP addresses around, and that can all happen quite quickly. So it has a similar effect to having a single IP on a proxy. But the issue is, if you're on a system like Azure that doesn't support VERP, then it's not going to work at all, and then it's completely useless, and you'll have to do something else. If it did work, it's probably going to be okay. I suspect, like a lot of things, it's probably going to be fine until there's a problem, because it's easy to forget about it being there, because it's just a tiny little daemon with a little config file running away doing its own thing. And like all of these, you're still going to have to understand exactly how this is going to fail over. What happens if a database goes down? What happens if a server goes down? What happens if it crashes? What happens if it reboots? That all of those things are going to be important, because in order for you to know your system's going to carry on running, you need to know what's going to happen when things actually fail. You know, you could say, well, it might only be 5 seconds of problems, but do you really want a couple of hundred users seeing a ton of error messages for 5 seconds just because you're rebooting a database server? So that's kind of important, but it seems like quite a slick idea if you're on a system that supports VERP. And you can even use like multicast across multiple subnets as well, which because obviously the ARP announcements are subnet specific, but if you're running on multiple subnets, you effectively need the ARP to work across subnets, so it uses multicast for that, but it's just more kind of setup. Another one which is more geared towards Postgres itself rather than just a general purpose solution is something like a hosted agent. So Patroni, they call it a template, but it's another one of these kind of a project that's been going on a long time that still doesn't really feel like it's a kind of production ready concept. So you know, with some of these, I'm not sure Patroni or not, they kind of say, oh, not really tested in production, or it's just, yeah, it's not really all there, you need to wire up some of your own bits, but it kind of feels a bit like a job for a specific purpose. But like a lot of these open source projects, it's not immediately clear what's the main purpose, because it will support some features, it won't support others. But here you're effectively building what might be called like a Kubernetes for Postgres. So the idea that you have an agent that's running, that's watching the cluster, it knows what it's doing, it can, you know, start up and shut down, it can fail over, but actually there's a lot more moving parts here, there's a lot more learning to do. Is it the right tool for the job? Honestly, I can't really say. It just felt like quite over complex, and felt like you had to set up a lot of pieces in order to get it working for what basically should be as simple as some instances and a load balancer, a bit more like HAProxy. The cloud specific ones, again, I don't really know. I haven't had much experience of using cloud specific management systems. I suspect they're probably okay. They're probably fairly basic functionally. I don't know if they support primary versus read-only, but you know, they're going to probably be the simplest in terms of hiding all of the details from you, and they're likely going to charge you money for the privilege, so by all means investigate those. And there's a couple of kind of open source projects that, again, they kind of make me feel a bit uneasy. So this PG cluster sounded like it was the original project to basically solve all of the things that we're talking about, but then it kind of didn't really get very mature, and then version 1 kind of got abandoned and wasn't even released yet, and then version 2 came along, and then then it requires 3 database servers, you need a separate witness, you need 2 load balancers, so it all starts feeling quite complex already. But the other thing, and again, it's really hard to deduce from some of the websites for these, the websites look very old, they don't look like they've had anything changed on them, but the site is still there, which is a bit unfair. I think it needs to be clear on these pages if it's like this project's been abandoned, or even it's been mothballed and it's been sat there for 10 years, then you should put that at the top and say, look, don't use this for anything at the moment, we're not really maintaining it. If you want to have a play, then have a play. But yeah, it does appear to be abandoned, so I'm not sure that it's really going to be any good. The one that probably looks the most promising, or or the most modern, I guess, the most up-to-date is pgcat. So this does pooling of connections, which we haven't really talked about, and it also does a proxy like pgbouncer. So it kind of does the load balancing bit, but the documentation again pretty patchy, pretty hard to understand. And I think the kind of the big letdown for this is that the primary and the replicas are defined statically in config. There's no health check mechanism to say, are you still the primary, are you a replica, a bit like we saw with HAProxy. And because that doesn't exist, it would mean if you did fail over, you would actually have to update the config and restart that service. And to me, that's a massive letdown, because that's the last thing I want to be doing when something's failing over. I want to fail over and I want the system just to know that I failed over. So it's kind of modern, but I don't really think at the moment that it's quite up to the job. And then the last one I mentioned is pgpool2. So it calls itself a middleware. So again, it's something that gets installed into Postgres itself and supports various HA options now. Like with all of these, there's going to be problems with it, which may or may not be problems for you. It has to be built from source code. Now, you might be the sorts of companies that build everything from source, so you might not care about that. For some of us, we're like, I really don't want to be building stuff from source. It's just another variable, another thing that I don't know enough about that's going to go wrong. I'd much rather have it in the package system, but it's not in the package system, so what we're going to do about that. The documentation format, again, it's a little bit like the rep manager docs, where you kind of have it page by page, but it's quite hard to navigate. It's quite hard to kind of see where you are. So I didn't really find the documentation that enjoyable, and it's still maintained, and it's probably, reading between the lines, probably the most complete Postgres specific solution compared to all of the others that I've seen. But again, it still feels that little bit like I'm not 100% sure that this is exactly what I want it to be. And it runs in a number of different modes. It has the ability for pgpool to actually manage the replication for you. So rather than you writing to the primary and it replicating, you can write to pgpool, and pgpool can replicate to each of the databases. Now, to me, again, that's a significant single point of failure. So then you'd have to make that highly available as well. So yeah, not entirely sure, but you're welcome to look at those. But hopefully, unfortunately, I can't kind of give you an answer to that. There isn't a one solution that everybody uses, unfortunately. It still requires a lot of kind of understanding and a lot of evaluation. But hey ho, that's kind of the world that we live in, and PostgreSQL doesn't cost anything, so we can't really complain. You could always pay somebody to update one of these projects if you really felt like it. But what we're going to look at in the next video, the last video, are basically the different failover scenarios. What happens when, how do we update stuff, how do we fail over, how do we know we failed over, how do we deal with the applications, all of the little bits and bobs. And because we've invested so much time in all of this setup of our cluster, we've got HAProxy. We're going to use that because it sort of makes the most sense for us at the minute. We're going to basically get to see how this might actually look, and then hopefully at that point you'll have a much better idea of how clustering works in PostgreSQL. So I'll hopefully see you in the next video.